All right, so today we're going to talk about section 4.7 for 1151. So the next section is assuming that we've already kind of talked about Lewis structures and we also have our shapes kind of down, working on those shapes. The next thing we need to talk about is electronegativity and bond polarity. And so we're going to back up a little bit and talk about individual chemical bond features. Electronegativity is a measure of an atom's attraction for electrons in a bond. We've talked about this in class a little bit, but it basically tells us how much in a particular atom wants to gain electrons. So if you're in a bond with this atom, how hard are they going to pull your electrons that you're sharing? So think about it as a tug of war. A high electronegativity means that's gonna pull a lot more than a low electronegativity. So if we look at our periodic table, we see that good old fluorine has the highest number. And then if we were to think about francium down here, it would have an even lower number. So increasing up and to the right. So think about fluorine as having the largest electronegativity and francium having the smallest. And that's actually the case in this one because we don't talk about electronegativities for noble gases because they don't really bond. So we can't really get values for them. So when you have an interaction, where you're sharing equally or about equally, then we call this a nonpolar bond. So if we look at a C-C bond, so two carbons bonded together, they have the same electronegativity values. So if you think about tug of war, they're pulling exactly the same. Nobody's going to win that tug of war. So we call this a nonpolar bond. It's not like someone is being a bully and not sharing well. They're sharing perfectly well with each other. They're actually equal in how they share. Another nonpolar bond, so pretty much for this class, what we're going to learn about for nonpolar bonds. There are more nonpolar bonds than this, but I'm not going to have you memorize all the possible nonpolar bonds. So you're either going to have CH, I want you to know is nonpolar. That's a really important one, especially for Chem 1152. So CH is nonpolar. And just any bond of two of the same element. So if it's two of the same element, or CH, we can consider that bond nonpolar. It means it's going to be shared equally. So the electrons are being shared equally. Nobody's pulling, nobody's winning the tug of war. It is just an equal sharing of electrons because the electronegativities are so similar. Now, if we have a difference in electronegativity that's a little bit higher, we would call this a polar bond. You can call it a polar covalent bond. The word bond kind of indicates that we're talking about sharing. So you'll hear me just say polar bond a lot of times, but I'm talking about polar covalent bonds. And we can also call this a dipole. So a dipole is literally the polar bond. So CO is an example of a polar bond. It has a dipole. We draw this little arrow to indicate the direction of who is winning the tug of war. So if we look at the electronegativity values, we see oxygen is 3.4 and carbon is 2.6. You do not have to memorize these values, just know the general trend. Because they're two different atoms and not CH, we can consider this bond polar. So for this class, we're going to consider a polar bond as two different elements in a bond, but not CH. I want you to know that CH is nonpolar. And of course, this is an oversimplification of this. It's just for this class, so you can kind of get by without having to memorize all the possible nonpolar bonds. There are some elements that are two different elements besides CH that are nonpolar, but they're not going to be really that important in this class. So basically what's happening is we have a tug of war happening here. The oxygen is pulling the electrons more than the carbon because it has a stronger electronegativity. It wants the electrons more. And so we show an arrow pointing in the direction the electrons are being pulled. And then that makes the oxygen going to be a little bit negative. So we use this little symbol here. This is a little lowercase Greek delta. Kind of looks like a fancy S or an upside down G. We're going to use this symbol and a little negative sign to designate oxygen as being a little bit negative. It's a little bit negative because it's pulling electrons towards it. Electrons are negative, so if you pull negative electrons toward you, you're going to be a little bit negative, which means that the other atom is going to be a little bit positive because it has its electrons being pulled away. So the carbon gets a little symbol saying it's partially positive. So this little symbol delta means partial charge. So partial negative on the oxygen, partial positive on the carbon. And the dipole kind of gives you that information in a different way. It shows you the electrons being pulled towards the oxygen, and we put a little plus sign on the other side of that arrow indicating that the other atom is a little bit positive. So this is an unequal sharing of electrons. If we had a tug of war, oxygen would actually be winning. Oxygen, imagine, would just be dragging carbon along in that tug of war. There's nobody really pulling on the other side of carbon over there. So all the electrons are being pulled towards the oxygen, making the oxygen a little bit more negative. And this is important when you go into the next class for Chemistry 1151, because this is going to make carbon-oxygen bonds a little reactive, because the carbons being a little positive and oxygens being a little negative, that can attract different other types of molecules with that have different polarity of their bonds as well. So here's a little summary. You do not need to memorize the differences here. Again, for our class, we're just going to say nonpolar bonds. Don't really worry about the difference. If you want to do, maybe for homework, you need to actually sit down and calculate the difference, that's fine. But for the class, for quizzes, for exams, all that fun stuff, you're going to know that CH is a nonpolar bond or two of the same element. That's it. And then a polar bond, the book is calling it polar covalent. I'll probably just say polar bond, is going to be two atoms of different elements bonded together, but not CH. And then you have ionic. Ionic is so polar that we don't even play tug of war anymore. It's just like if the oxygen were to just to pick up the rope and take it. Like you just transfer electrons. And so eventually you get to be two different where one of them isn't even going to hold the rope when you're playing tug of war. And so that's just an ionic interaction. So this is kind of a scale where we get that ionic. That's why some things are ionic and some things are covalent, is because some elements want electrons and they'll hold on to them, and so you'll have a covalent interaction. Other elements don't want electrons enough, and so when they encounter an element that really wants electrons, they'll just let them have it. Like the electrons just get taken, and that's ionic. All right, we'll go to the next video for the next section.